brief for people especially joined today. So I think we are the last few sessions we are trying to compare the various services between AWS, Azure, and GCP. So in this process, actually, we looked at what is common also, and then what are different. And yeah, there are so far we see a lot of things common across various clouds. So we looked at regions and zones which are the same within AWS, Azure, and GCP. Compute, the four pillars that we probably looked at is compute. The compute, what is virtual machine infrastructure as service, platform as a service, and also the next. Those are all VM based, and then we evolved into the latest containers and orchestration and Kubernetes and serverless. So that is at the compute section. We did a comparison, and then we looked at databases to compare between AWS, Azure, and GCP. And we also looked at messaging differences, web application, what are the differences, networking. We looked at various different aspects within networking. Networking list is very big. So, and then storage, we did a comparison of storage. Especially we looked at various options of storage like object, virtual disk, file storage, data transferring process, and hybrid storage. And we also looked at the big data and analytics side. So what are data warehouse equivalents, big data, and data orchestration and visualization and analytics. So we looked at that. And also in the DevOps area, we looked at how is it different, starting from monitoring, logging, auditing, and code compilation, code build, developer tools, and what options we have for monitoring, application monitoring. And then it's all for developers, but I think for management or for senior management in the organization, they'll be interested more on some tools like getting the billing reports, security risks and management from security point of view, and monitoring, overall monitoring, then health dashboards of the services of the cloud itself, and cost management services and application insight services. These are all more on management level view. And also we looked at mobile. How is it different? The mobile space within three vendors. We also looked at security. How is it different with various vendors? And also looked at encryption and firewall. And more in detail, like additional security tools that are available. And yes, now today we'll deep dive into AI and machine learning services. So I think let's start with this. I think that this AI and machine learning area is quite huge, and there's a lot of traction in the space. And every cloud vendor is competing. AWS, Azure, and GCP, all three are competing in this space, and so many tools have evolved in the last 1 year time span. But I think the flagship products that, if you have to remember, the flagship products of cloud is in AWS, it is SageMaker. If you have to remember one tool which connects everything on the machine learning is SageMaker, where it comes into the category of basically a lot of noise. Can go on mute.
Hey, I'm sorry, it's me.
Okay. Yeah. So in the category of training the models and deploying automation and managing the ML models, so this is a common use case in any cloud to start with. I think generally in any machine learning projects, generally you have a lot of data, and then you train them, and then probably you come up with an ML model and deploy the ML model, and probably automate that ML model with any of your existing applications or to our existing workflows, and probably manage in sense like you have to upgrade newer version, redeploys and other things. So this is a common trend. So for supporting all this end-to-end ML, AI/ML services, the flagship products in the respective tools are in AWS it is SageMaker, in Azure it is Azure Machine Learning, and in GCP it is AI Hub. So, but this is a flagship product, but but the use cases are very different in AI/ML. So there could be use cases for uh, for voice-based communication, chat-based communication, text-based communication, video detection. So a lot of categories are there in this AI/ML space, and they have specific products for a specific area. So probably let's look into the specific use cases, specific requirements of where the tools are available. So start with first, I think if you look at the bots, intelligent bot detection, or building a chat bot, and connecting the intelligent bots with your existing application or interfaces. So the tools in that area are the second one, which is the second one I'm talking about, the Alexa skill set, which is primarily Alexa is a voice-based integration tool, and that has more popular in the after this Alexa has become this tool as Alexa is more prominent in the space now, and there are a lot of skill sets are being developed around that space, and that is now possible to integrate along with AWS SageMaker. You can improve, and you can come up with your own skill set as well. So that's the area where AWS has this tool called Alexa skill set. In Azure, it is Azure Bot Framework. So and in GCP, it is Dialogflow. So this Dialogflow in the GCP space is more. I mean, from the name itself, you can train. It's just like a chatbot or Alexa, where you need to train on a specific domain, so it can understand the domain well. And once it understands the domain and it can communicate to the questions, probably you have to train. Once it understands the domain, you should also train the model more to give a better outcome in terms of speech or the way it communicates. And then once you're good with the training data set, probably you should apply it and then re-engineer it or modify it or make it even better. So that's the general trend in this bot space. So and you'll generally integrate this with any of your customer-facing chat line or support line. So that's a common use case in this area. So yeah, that's about the second row. The third row is more about I mean the speech to text and text to speech conversion. I mean the third row talks about the speech to text. So converting a speech to text. I mean we have even in CNN, or if you see there will be a person will be in the CNN news channels and all. In most of the news channels, for example, people will be talking and behind, and there will be a text that will be rolling behind. Or even in YouTube, we have a lot of you can enable the text which will convert that conversation into a text. So yeah, I think that is doing it live is not easy. So it should understand the tone of the person and the language, the style. So it should understand all those things and it should do the conversion. So in that space, and everyone will have their own vocabulary or the way where they have their own style of speaking. So understanding that and then converting it to a natural text is a big skill set. So in that space in AWS it is Lex, and in Azure it is speech to text. I mean the cognitive services is a broader umbrella in Azure. Under that we have various categories. In GCP also it is a broader umbrella of AI building blocks. That is a broader umbrella. Under that we have various categories. For example, this one will come under the category of conversation. So AI building blocks conversation will help you to do that. And the next one is the fourth one is the natural language understanding and integrating of that with apps and bots. So in that space, again, it's a similar one, but it is more integration towards your apps and bots, which makes sense because you should when someone talks, you want to also convert the conversation to text. So it should be useful for a future reference. There are a lot of use cases that will come under this category, but it's more integrating your natural language to apps and bots. In AWS it's the same Lex, but I think in Azure Azure and GCP there are a bit different. In cognitive services, Louis is language understanding tool, which is more popular, at least in the language understanding area. Lex and Louis are nowadays competing, but yeah, of course, AI in the GCP after GCP came, this GCP's AI building blocks language also is in the space. This is one of the initial when all this machine learning is all coming. So the speech to text is become so popular, and also integrating with the chatbot is a super duper combination. There's most, I think nowadays we are usually it's all are very pilot now. In real time, we are in our day-to-day life. Also, we're seeing a lot of integrations happening now. So, and most of the customer-facing organizations are almost migrating towards this chatbot or natural voice-based integration. So, I think behind the scenes, if they're using any of these cloud vendors, probably they're using these tools. And the fifth one in this category is primarily enabling the speech to text and also the text to speech. It can do both. So that way, in that category of the two-way communication, then we have tools in AWS called Poly or Transcribe. So the name Transcribe Transcribe tool is primarily used for medical, especially the use case or this tool is primarily meant for medical transcription based domain, especially because that was legally trained in that space. So it can replace a human in terms of transcribing the medical transcriptions that the doctors or junior doctors, whatever they dictated, this will be transcribed in real time. So that is that space where AWS this transcribe tool is more popular. In Azure, it is text analytics and speech services. So combination of tools. And in GCP, it is again the language under the AI building blocks. So that's about the text to speech. It's all more about the text analytics. This summary is all text. The 3, 4, 5 rows are all speech to text analytics category. And the next one is the computer. Yeah.
Yeah. So one update is AWS is one of the leader in these machine learning side so far. First of all, with the usage of Alexa, that made the whole thing became very popular. People start using that, and then they converted as a chat box with Alexa, right? So to enable a call center solution, in those days it is one of a very costly investment, and you need to have so many call center agents to be there. But now with these automated things, most of your order queries will be answered by Alexa itself. And if something has to be escalated only, then it will be channelized to the humans kind of a scenario now. Actually, it reduced lots of call center, the employees side of it. If they really want to automate it, yes, they could take it to the next level. Kind of scary though, but that is the power of the technology here. Along with that, with the SageMaker, right? That SageMaker is the machine learning that is all composite. You could write anything, right? Because it's just a box where you could put your code within that. So yeah, with the AI, whatever built with this Alexa and Lex, if you really want it to the more custom way, you could augment with your custom solutioning around the SageMaker side of it. Azure is there, but I don't think it is that prominence on this area yet. People have started using it. I think Google side also, I would say that they have TensorFlow. That is one of the things Like they bought the Kubernetes, they bought the TensorFlow to the open sourcing side. That is a cool technology. But the problem with all those things is it's all open sourced. So whatever the merit of those things, it's available to AWS and Azure also. Yeah. So Google is also trying to bet on this, but all these Azure and Google, they are all investing heavily on this space because, like I said, those four pillars are there in all the cloud everywhere now. But only differentiators are going to be this side where there is a huge opportunity across verticals also.
Yeah, exactly. I think whatever we are seeing is the initial products that came in the AI and ML space, but I think now the trend that we're seeing here is all these cloud vendors are going vertical specific use cases or vertical specific products, so that because a product supporting a domain A may not 100% suit for a domain B. So I mean, medical may not suit for example, for an insurance. Medical can go together, but insurance and probably finance may not go together, for example. So they're now going towards. I mean, there's all a lot of domain knowledge is required to train these models. I think that without that, this can't definitely replace a human. So that domain knowledge, building the domain knowledge is what is the core in this, or the challenges that all these cloud vendors are now trying to solve. So yeah, in that space, they so far whatever the last one year or 1.5 or 2 years, so they're all tried on various tools around the common utilities like doing a voice or speech or text or video, or so they solved that problem, and then slowly they moved towards a developer framework. I mean, with a developer framework, because all these tools can help only if there is a proper integration that can be done, and proper implementation, developer friendly development studios or development IDEs, and integration with existing products. So there are a lot of libraries around making it developer friendly. So that was the second wave, and then third wave, which is going now, is all okay. They have all the base products ready, and they already piloted with their own products. For example, Google has integrated most of the services with their own products. For example, Gmail, we saw like auto detection of your compose, right? Even you compose an email, it will auto detect and fill the words for you. So all these things like this, all these products are tried and tested in their own domains, and now they're kind of in a stage where it is ready to it will work. They know it works now. So now it is the next trend is to applying for various use cases or industries. That is what the third way of trend that is going on now. And I think, and in fact, if you see the latest AWS reInvent happened, all the all the tools that AWS releases in the machine learning space is all catering towards every vertical. I think we saw a call center vertical, which Srini was mentioning. And also there's a lot of verticals on industry IoT. So industry manufacturing, where it can we have Vision API that they developed. So using the Vision API, using camera, so it can detect if there is any flaw in any particular product, yeah, which is running on a pipeline. Right? So how to identify a flaw in a particular product when every product is going in the super speed, how it can in that speed how to detect a flaw in a particular product. So like it is again industrial use case. So likewise, they are going now towards industry specific use cases now. So I think that is what the trend is going towards. Yeah, but I think what we're seeing is all the building blocks for that. So it is not possible for all the providers to they can come with a generic solution, but they can't make it very specific to your company's requirement or your enterprise requirement. So they can't be that specific. It is impossible. So to that, that's where our as a developers we will be as architects or developers we will be in that space to make it the generalized product, make it customized for your organization. That's where we get jobs in doing that if you're into this space. So in this process, you need to know about this product at a high level and also some basic knowledge about how this entire machine learning services work, the life cycle of this process, and then probably, yeah, and then you have to pick a framework. So and all these cloud providers picked up some frameworks, either in terms of in open source, where I think most of the areas in the machine learning is all open source. They each one picked one open source technology. For example, GCP is TensorFlow, Azure is MXNet, then AWS. I mean, even though TensorFlow is open, but even they have Azure also has TensorFlow and AWS also has TensorFlow because it's open source. Similarly, MXNet is also being used in other places. It's all all are used by others also just because of the competition, but they selected one, but they support others. So that's the model that they're going. So like this, yeah. Azure selected MXNet and AWS selected DeepRacer, and also MXNet also is there, and also PyTorch. So that is also is popular. So yeah, so likewise, yeah, it's more about into this space, understanding the domain, and also to understanding the machine learning services, understanding the product as such, and probably using how to integrate that into your existing applications. So because you know your applications well than anyone else, so that's where your job will be there to help integrate that with others. So yeah. Okay.
Yeah, one more interesting use case is from the video. Now every street has a street camera across the globe, and how to make value out of it. Can you make crime things much lesser, because now it's all captured, but just capturing video, you have to go and look at that 8 hours of video to see who did that as a chain snatch or whatever it is, right? But with this computer vision face detection things, what is happening is this is the happening right now. Proactive, basically, as the video is being streamed, you could able to see what is happening out of it. Basically, you could compare the images with the past images to see, oh, is it kind of a crime, and can I alert it, kind of a thing. And also, when the video is there, you don't just have the picture, you have the audio along with it, right? So can that audio also be used to to understand the context better? So we are in very early stage, but probably in another 2-3 years, this is going to be the prime spot where everybody, when you are going out of the house, everything is wherever it's being recorded, that could be alerted very cheaply. The technology is so cheap. For these kind of things, if you have to do your own, it is very tough. But the technology has matured with these cloud providers, right? Like I told, in Pacific Gas Electric, we are using a computer vision model for the wildfire alerting, right? But still it is in a premature stage. Once that is real proactive alerting, that is going to save lives, real lives, because when the threat happens, it's a real-time threat. And when the alerting happens in the real time, in those kind of situation, wildfire situation, it could save a lot of life. And that is one classic use case. But there are many use cases where this is going to be very cost effective. But this kind of solution cannot be possible before. Now it's prime time.
So Tini,
Yeah.
one of the biggest case study on this one is on the China, where China is using extensively this technology to track the minority Muslims in one of the provinces.
Wow. Okay.
So it is one of the most blatant violation of human rights, but it's going on for years. Uh, so 80% of those, probably people, some of you may know, 80% of the security cameras in the world is manufactured by one company called Hikvision, which is a Chinese-owned state company.
Mm.
And people are worried if that has got a backdoor. I mean, every camera, security camera in my house or your house, even the government buildings, they all manufactured by them.
Mm.
And they used this for years in the streets and the public places in China, and to track these people. And they track and identify something like 50,000 unique faces every day. And their profiles are collected, they are tracked, and they are monitored. And this is going on for years now in China.
Wow. Yeah, yeah. And the thing is, the camera is so cheap so far, but now analyzing the video on the real time also is so cheap. And if these two join together, it is going to be a revolution, actually.
Yeah, that's true. Okay. Yes, I think. Yeah, so I think a lot of updates happening in this space. I think yeah, keep a watch. So yeah, probably let's continue on this space. So I think so far we looked at this the voice based stuff and language based. So I mean, you can logically I see this the naming convention from GCP is logical because it's a more very yeah easy to understand. I mean the A building blocks conversation. So yeah, and A building blocks languages. This makes sense because it sticks your mind more quickly. Yeah. So I mean, you can refer this slide, this section, so that you could relate which area that we are in. I think let's come to the site or the vision. So yeah, this computer vision, face detection or emotions. This is I think what we're discussing now on the video based integration. So I think this one is more you need a device which can capture the video, probably a camera, which can also from based on the events in the video. It is also possible to detect a lot of emotions that are there in the video, and also it can do a face detection. Let's say out of 1 hour video, you wanted to look for a specific image if that is available or not, a specific person's image is available or not. So that can be done with these tools now. Earlier, it is you should do this manually, right? So all those so basically particular scenario you can give it, and then it can check whether that scenario is available in that particular longer hours of video. Generally, all these videos of home security or all these cameras that we have, so they'll run continuously, right? So it will generate loads and loads of it'll generate a lot of video content, and probably to filter or streamline or narrow down on a particular event or a particular phase in the videos, it is a bit tricky. So yeah, I think all these tools will help you to do that now. AWS recognition, in AWS it is AWS recognition, REK, for that. That's just a thing to note. So AWS recognition, and in Azure it is computer vision, Azure Cognitive Services computer vision, and then GCP it is site, a building block site. So, yeah, the next in this space is more about uh, it's more about making a developer friendly and make this make this AI usable for a common developer. So, I mean, all these machine learning services require a machine learning expert or a data scientist. That was the situation earlier. But I think for most of the common use cases, I would say common is a keyword. So, most of the common use cases, now this trend is improved to come up with an auto ML or auto AI services, where you don't need to have AI ML expert for a common use cases. So these auto ML services can do most of the job for you. So you don't need to spend, as an enterprise, they don't need to spend on a AML developer or an architect. So yeah, basically it is replacing more or less us in this place. So yeah, it is more. The last item is more auto category. Auto is like auto developer or auto ML or auto implementation of a. If you have structured data, it can understand and apply machine learning on its own. Rather than you training it and you giving input, or you as a developer or an architect, you giving that, you're training it and you are deriving an ML model and then you are integrating it. So all these things will be replaced with an auto feature if the data is very standard, and if it is coming under a common category where it's already a solved problem, then yeah, so then this auto category will help you. So yeah, the last category is primarily to empower the professionals and non-professional data scientists to build the machine learning models more rapidly. So in that category, in AWS, you have SageMaker Autopilot. So and also in the Azure machine learning side, so automated ML, and in GCP it is structured data. So AI building work structured data. So basically, these tools will help you to address your common use cases where yeah, you don't need to go through the entire pain process of training, deploying, automating, managing your ML models. All these things will be taken care by these tools itself. So yeah, that is one area which is getting popular now, right? And then moving further, this also, yeah, there are tools which are easy to understand the visual interface. There are to basically, the visual interface is what is important for this ML AML category, where you need to have visual interface to understand, build, train, and deploy the custom machine learning models. So so standard models are there, so that's where this auto ML will take care. The previous category that we saw, these are primarily for standard models, where it can apply the for the standard data model, it can do most of the job for you. But if there are custom models where your own domain specific ML model, then it is, you need to have some developer friendly tools which can help you to develop this custom ML models faster. So in that space, to develop a custom ML model faster, in AWS, SageMaker is a broader tool, but so that comes in this space. In Azure, it is ML.NET Model Builder. So this is ML.NET is the area where Azure is betting on this ML.NET tool. So this is primarily for machine learning for .NET folks. But it's all developed on .NET based integration. So especially for machine learning. So like how TensorFlow is embraced by Google, ML.NET is from Azure. So yeah, so ML.NET Model Builder, and GCP, it is again the same thing, the structured data, AI building structured data. So that's about the model development. If you go further on this model development, yeah, this you should also, I think, to extend the use case that we saw on this computer vision category. So this computer vision face detection, we also discussed about identifying a particular scenario in the video, or extracting insights from a video, and or discovery of a particular person in a video. So in that category, so recognition, which is the same thing that we saw here as well, the same thing. But in Azure space, there's a specific tool for this called Video Indexer, Azure Video Indexer, and in GCP it is Cloud AutoML. So this Cloud AutoML will also help you to identify the videos and discover the specific category in this in a particular insight, extract an insight from a particular video, and also discover a particular person or an event in a video. In that category, these tools will help you. Yeah. So next is the category of training a bot. So so nowadays even training a bot is also getting complex. I mean, so now initially the tools that were there is that you need to do a lot of training for a bot to talk like a human. So, but now if you look at any common FAQs. I mean, most of the companies will have FAQ pages or product manuals or some websites. So most of the information about a particular product of the enterprise, they're all available in this document manuals, like FAQ pages or product manuals or websites. So so it doesn't make sense to provide or feed this information if any of these tools can, if you give just the input of your FAQ page or a product manual page, so it can scan through that and it can learn on its own. So that's a really cool idea. So instead of you training them, you give all the reference links and tell, hey, go and read this and come back with your knowledge. So that is a space. It's a very interesting space. So in that space, so there are some tools in this cloud vendors like AWS Chatbot, Lex, and Kendra. AWS Kendra. So this is all these three tools combination will give you this feature where you can give the links to the ML model and it can go and read and gain the knowledge from it. In Azure, it is a Q&A maker, cognitive services Q&A maker, and in GCP it is Cloud.ml. Next is the developer-friendly tools. So in that category, all the I mean, Python is most used language in this space, and this Python is, as we know, it is an interpreter where you can write all the code in Jupyter notebooks. So basically, you can maintain the code of all the machine learning in development that you make. You can all maintain in notebooks. Notebooks is something like your like your wiki page, where you can think that as a wiki page where it can understand the code. So basically, you can type your Python-based programming language for a particular requirement, and then it can, if you just you can run it and it can show the output just below the content itself. Basically, you can write a code, see the output in the wiki page itself. So that is what is this. So also you can write documentation for that, and also you can share this code to a particular another person, so to get reviews. And so basically all developer friendly tools for this machine learning development. So yeah, so that's where this notebooks will Jupyter notebooks are very popular in this machine learning space for developers to share and maintain the code. So in that category, AWS has AWS SageMaker Jupyter notebook. Whether Jupyter is an open source company, I mean open source software where they gave this Jupyter as a company, they outsourced their notebook product. But that is now become so popular that everyone started using it, and now all these cloud vendors have their specific notebooks that were integrated with Jupyter inside. So yeah, so the AWS answer is AWS SageMaker Jupyter notebook, and in addition to that, I mean, you know these tools are there, but there is always very well you can install, set up your compute in this respective areas. For example, in AWS, you can create a virtual machine and then install Jupyter manually. That is also possible. But those are all like infrastructure service model where you are creating a virtual machine and then installing Jupyter, which is free. Right? That is one way, but that you can do. But in addition to that, if you're looking for a managed version of this, then you can use this respective products. So yeah, AWS managed Jupyter notebook setup is SageMaker Jupyter notebook. In Azure, it is Azure notebooks, and in GCP, it is AI platform notebooks. Okay, so then the next category is is for developer again, where if you're looking for a pre-configured environment for the data science and AI. So the I mean it is setting up the environment is one of the tedious tasks in the data science world. If you have to set up a new environment, you need to install so many library softwares required for this based on what type of area of machine learning that you're working. So it could be a deep learning, or it could be a pure auto, it could be a normal ML based, or it could be any specialized services. So it depends on what type of areas. But most of the common installing software is a common problem or pain point. So that has been now addressed with pre-configured environment. So we have a machine images or images of this. What are the common softwares that you need? We have an image. Basically, you can download that image and set up your virtual machines in the cloud. So you don't need to install this, this. So you don't install so many softwares. You might forget the sequence and other things. So that's why they have a ready-made image, but it's called deep. For example, in AWS, we see AWS deep learning AMI image. AMI is like AWS machine learning, so machine image. Sorry, so AWS machine image. So you get a machine image for all the popular use cases of all the machine learning softwares pre-installed. So you can use that image and you have everything set up, so you can start the development immediately. So that's the pre-configured environments that you get. So in AWS it is deep learning AMI, but there are quite a few. I think in this I just put deep learning AMI, but I see AMI for so many categories in this AWS space. I just put one, but I think there are so many here in this category. You have specific, at least I saw around 30 plus AMIs are there under this category. So it can be very specific what you need. Whereas in Azure, it is data science virtual machines. So data science, I mean VM at the end, but it is pre-configured VM. That's all. So for data science, so which has all the data science utilities already preloaded. And then here in this GCP, it is deep learning VM image. I mean, why I put deep learning here is because I mean, for deep learning is an area in machine learning where you can't achieve this with one software. I mean, there are so many libraries that you need, especially in the Python space. So you need to have so many libraries that you need to achieve the deep learning requirement. So installing all the Python libraries, or if you're not a Python guy, probably or any other alternatives of Python. You need to have you need to install so many softwares to get going on your development. So all this, so that's where this will save time here in this space. Right. And then so next is the compute requirement. Right. So normal compute may not be sufficient for your the type of. I mean, it depends on the use case, but most of the deep learning based machine learning services would require so much of compute, and so generally we use CPU, right? CPU is what we use for a normal requirement, but for a video based deep learning requirements where the CPU may not be sufficient, you need an extra CPU, which is called GPU, like graphical processing unit, where it has a graphical interface inbuilt in that, so that it can process the videos faster. So compared to CPU, so I mean you can do it the same thing with CPU also, but it takes more time. So the GPUs will save a lot of time in training a model, a deep learning model. Generally, the time initial days, all these GPUs all came. So the training is simple use case of a deep learning model will take at least 3 to 4 days just to train the model. And applying that model and then see there is a flaw and then retrain it again. So it will take another 3 to 4 days. So that the training time can be minimized with if you put a high-end machine there instead of a normal machine. You put a high-end machine. which is like having a GPU, graphical processing unit. It can do the same job in lesser amount of time. Probably in less than 10 hours, it can complete with a GPU. And even nowadays, it's all even coming down to hours. So yeah, the days are now getting converted to an hours with the so the training time is overall reduced. So with this high-end CPU units, high-end compute units. So yeah, so in that category, GPU is generally used for your deep learning machine requiremements. So in that category, AWS has a tool called deep learning GPU instances. These instances are nothing but yeah, it's just like a VM, nothing different, but just that this VM is not it has a GPU setup that is enabled. So and also it has deep learning in combination with the deep learning pre-configured environment with GPU enabled. So you are good to go for your development and testing. Yeah, so the same category for GPU enabled. Here in Azure, it is GPU support on AKS. This AKS is again the Kubernetes services, Azure Kubernetes services. So this Kubernetes services is initially it was not used, but I think now recently the trend is moving towards even using Kubernetes for all the machine learning requirements. You can consider. I mean, the flow is a bit different in machine learning, but still, initially, that's the reason there was a hesitation to use Kubernetes. But I think those are all being now addressed in Kubernetes now. I'll go through some other toolings which are specific to Kubernetes. Kubeflow is one tool within Kubernetes, which is dedicated just for machine learning requirements. So yeah, so now Kubernetes is now kind of tuned for machine learning requirements because machine learning is a different set compared to a normal flow. So yeah, in that. Kubernetes is nothing but your compute orchestrating your containers, right? So in that category, so far it's all trained for CPU. Now a GPU support is also added in Kubernetes now. So I think Azure uses that for GPU support. So it's a GPU support on AKS, and then Google world it is deep learning containers. So this deep learning containers will, I mean, in this container containers have become so popular. Even this machine learning universe also started using containers these days, and there are a lot of deep learning containers which are ready-made available in Docker Hub, where you can download these containers for free and start using it. And also there are a lot of use case specific containers also available, like deep learning, machine learning. So you can be very specific what containers you need. Yeah. In Google, it is deep learning containers is one which comes along with the GPU support. Right, and then next is data labeling. So another common problem in the machine learning space is you deal with a lot of data. So and it suddenly becomes a problem when you're dealing with so much of data. Whether you need to label the data, otherwise you don't know whether you processed it or not. So or you should probably or that is one use case, or whether you processed or not is one use case, or let's say you want to add more metadata to the data point. For example, let's say you're processing images. So you have a lot of images of, let's say, cat, and so you processed an image, and that was an image of a tail of a cat. So then you want to highlight that it is a cat, plus especially it is a tail of a cat. So these are all labeling information or metadata information of a particular data point or image in this case. So this data labeling will help a lot because when you're reprocessing the same data again for the next time, which is very common in machine learning, so you have the processing will be more faster because it has a metadata already embedded on the data point. So that's why it's called data labeling. And the data labeling is so far the most time-taking process because it was all manual before. Because of which the training time is more. Again, to reduce the training time of a machine learning model, this data labeling helps a lot. So yeah, so for that, I think AWS, I mean, we have tools in all the three cloud vendors. AWS, it is AWS SageMaker ground truth, and here it is data labeling, ML data labeling, and GCP it is data labeling service. Okay, so yeah, next is the training services. So training a model is one of the complex landscape. So it is you should also take care of ensure the data that is going in is valid and also the data is correct and also training sometimes it can stop it can interrupt in between but it should continue from where it was last processed so otherwise you'll lose some time. So to manage this training, it's not the normal training. I'm talking about the machine learning training here. So the machine learning training is one of the pain point in the machine learning life cycle. So because it takes it depends on the size of data that you're dealing with. But if the data is huge, then the time it takes to train ML model is also huge. So to address that issues. In terms of some of the compute that you need for this training could be an on-premise compute, it could be a cloud compute or combination, or you want to speed up while the job is running. Our training is happening. Usually training is slow, but you want to speed up without interrupting the service, like adding external compute from behind. So all these things are the real life problems in training of AML models. So that is being addressed. That problem is addressed with these tools. I'm yet to fill the data for AWS in this space. I couldn't find it very obvious, but I think but there definitely will be a tool in this space. But in Azure it is compute targets, Azure ML compute targets, and in GCP it is AI platform training. So yeah, and also next is once you train your model, you should also deploy your ML models, and deploying your models and maintaining your models is also not easy. Meaning today you have version 1 model, tomorrow you train again, you have a second version 2 model. Likewise, you should relate the data that you processed. You should map that data to your model that is derived. So otherwise, it will be always a problem when someone asks why this was an inference, why this inference was made. Then you can tell that this is the data that was looked at to derive this output. So that mapping of your training data versus the model is not easy. So to maintain that or manage that, so you need to have some tools around that. So to manage the deployment models. So that's where this Azure ML deployments. Yeah, so Azure ML deployments in GCP it is platform predictions. So these tools will help you in that space. So yeah, probably is it too much of content, or do you want to take a break or talk something else? Or maybe I have one more slide, probably.
Yeah. So one thing is for the last two, you didn't put anything for the AWS, right?
Yes.
Yeah. Training services and compute management. Still, it's all SageMaker deployment and ML models through SageMaker. Yeah. SageMaker is one composite thing.
Yeah. I mean, this is one area is like the SageMaker. What I see is now has become a flagship product, but under that there are a lot of sub products are there. So we need to figure out what is that. So yeah.
Yeah. Yeah,
So
at least you could call it as the SageMaker now, but you could say the other things later. So just to give you a background, so one interesting area in machine learning is first you try to create the model, and the model creation depends on your problem at hand. For example, if you want to predict the home price, or if you want to predict the stock price, so that means from the structured data, so you have data about how the home is being sold in the last 10 years or something. This data is available across, it's an open data. So given that open data, so it's very interesting. Basically, once you have a data, can you able to plot the data? Yes, you could plot the data. And while plotting the data could be linear or non-linear. And mostly it will be non-linear. Except for a simple model, the data will be non-linear model. So given a house price number of years, you could take it in the x-axis, and in the y-axis, you could start plotting the house price. And if it is a big dimension, through Excel, you can find what could be the future price. But the real challenge happens when you want to have like how many bedrooms it has. Okay, then how many full bathroom it has. Does it have a half bathroom? Does it have more view kind of a thing? And does it have a good school district? So if you keep on thinking, you could keep on adding dependent variable. So when you plot anything, right, there is a dependent variable and there is a independent variable, right? So the more you get the for a given, if the for a given is a 1 or 2 dimension, you can even use Excel value. But in reality, the number of things at which your home price will change is going to be, the more you include, then only you get the realistic picture of your house price. That is where the machine learning comes into picture. So how to do that kind of multi-dimensional equation kind of a thing, right? So to do that, that is called you kind of try to find the base model, and there are some algorithmic things to come out with the base model. Once you come out with the base model is not going to help you. You have to train the model. That is where the real magic happens. Once you come out with the base model, you kind of train the model. Then you try to give. When you say train the model means you give the values, and you see the output of the house price, and see if that is close enough to the what is there in the market. So when you train basically, you know what is the value already, but you want to see if the model predicts you with that value or not. And if that is not the case, there are some mechanism to change the model itself so that you could come as close as possible. And it's going to take some time, but it is not that complex actually. But the reality comes is, the more dimensionality to the model and more the data it is, and you get the value of the house price for unpredictable, for for the futuristic house. So for example, if a house comes tomorrow, and you could say what kind of price is going to happen based on a model. If you have trained your model well enough already, adjusted your parameters, it's going to give you your value as close to the reality wise. And the fascination things happened is, for example, y equal to mx plus c and y equal to mx plus c. mx1 plus mx2 plus mxn dot mxn plus c, and as many variations to it, x1 to xn, your y value is going to be more realistic to your zip tone or whatever that you are trying to get at. So this is a mathematical puzzle, right? So, and how to translate this into an automated way is the machine learning thing. And I think the breakthrough has come from the algorithm and those kind of things. See, these models were there for a long time. 30 years before itself, all these most of these machine learning models were there. Last 10 years, it's matured a lot. Last 10 years, unstructured data like the image and video and get the value out of those things. So that has also come. So machine learning, mathematical models are becoming reality now. That's becoming reality now. But you guys see the connecting the dots here, basically from the abstract math into realization of that happening through this particular training the data. So once you come out with a model, your model might work for a couple of months, but it will not work after that. Your value, what it predicting, might not be accurate. What do you do? That means you have to train the model again. Where do you train the model? Where do you get the data? How to get the cleansed data? How that is where the data science. See that the whole value proposition here is this is kind of usually when you write a program and you get a executable, when you run it for enhancement, you go. But then if it is bug free, you don't have to touch it. But machine learning is not that way. Machine learning is you kind of came out with the model, you trained the model, it started giving you some predictable value, agreeable value. But if you just sluggish with that, your model won't predict properly because it has to adjust to the variance of your data. And the data should be a real-time feed. So whenever you have a real-time feedback to the loop, whatever it predicted, that also has to be fed to the training side of it, so that next time when it predicts, it knows from the mistakes or from the accuracy of what it predicted, and it's going to give you a better solution. So it's very interesting that way, like even though it's a regression problem. So for example, it could be a linear or it could be more than linear, and it could have multi-dimension of it. And the beauty comes because of the feedback side of it. All these are mathematics. You could do whatever I said is in the equation, but all the equations are being realized now through this. And one more interesting thing is how this is possible. Like last 10 years, it was not that possible. Why suddenly it became possible is because of the containerization. So it is kind of, you never know. These are all technology, diverse technology, but diverse technology is what connecting the dots. So that you don't need to have the VM. Previously, you need to have a VM for running everything, right? VM is expensive. Now it's all containers. Container is, you could run many containers within a VM, and deep learning VM. Previously, it was deep learning VM, but it wasn't that realistic, right? Because these are all GPU machines. You cannot have so many machines. Now it's all deep learning containers. You still need to have a GPU machine, but you could run as many containers as you want. And like what Sham said, like auto ML, right? That auto ML, it's also a very scary thing. Giving this to the business users. So slowly what's going to happen is the data, who knows data? Data scientist. Data scientist might not be a technical guy. They're techno-functional, mostly functional guys. Like a business rules domain. Who knows business rules? It's kind of a functional side of it, right? They know what to do for business rules for the particular domain. Similarly, the data, they know the data lineage. They know what what not worked, those kind of things. And how, so I said 70% of challenges in the training the data model, and the training the model is going to be simplified through kind of an AutoML approach. And the more the data, more visible, more queryable, more understandable. When we say data here, terabytes of data. That is one of the thing, right? It is not relational data anymore. This is a data warehousing data warehousing on the top-notch side of it. And the challenge is structured, semi-structured. Nowadays, semi-structured is also considered to be structured, like an Excel or a CSV or JSON or something, right? Along with it, unstructured data, the video and audio, how to correlate all these data together. It's very interesting domain.
Yeah, I think I just looked at this model, the workflow of in machine learning. So I think if you understand this, so you can appreciate the tools that are coming around this. I mean, this is a very common machine learning model. I think it's from AWS, but I think this is common for any industry for that matter. So generally, your life cycle starts with machine learning starts with fetching the data. So first, you need to know what are your data sources, where you have the data. It could be specific domain. Either you have data in structured format or unstructured format. But understanding the data, fetching the data is first thing that you need to do. But the data sometimes may not be clean, right? I mean, it may not be in the format that you're looking at. Probably it is in.
Most of the time, it won't be clean. That is
exactly. So the next obvious cycle would be to clean and format the data that you have. So the next, once you clean and format the data, next is you should probably prepare and transform to train your model. You need to probably add more information or remove information or probably change this. For example, 20. Let's say you want to remove decimals from your data, for example. So basically, you want to transform the data. So most probably you need to transform the data in a format where it is useful. Probably the data is not in a string. Probably you should convert it to a string format. So likewise, a lot of requirements. It depends on the use case, but it's mostly the transforming the data is also one of the pain point. So this is all at this stage. You have proper data in hand. Now this is all manual work. I mean, there's nothing to do with machine learning. It's all your data, and you are making it in a usable way. So there's nothing machine learning involved in this step. The machine learning starts from here. So training the model, right? So this is where so in machine learning everything comes with a model, right? I mean, you will evolve that model over a period of time. The output of your training is a model. Model is you can call that as an intelligence. Or model is equal to intelligence. That intelligence is what is output that you get. And so first to get that intelligent output or a model, so you need to feed that data that we have and train using your machine learning algorithms that you have. It depends on the use case, which algorithms are going to use or how do you manage it. It depends on your use case. But mostly most of the algorithms are ready-made. But only thing is you need to know which, for a given scenario, which algorithm should be used. So that comes with some knowledge on machine learning. So with that you will train the model, and once you train the model that you get, it may not be, as Srini said, there will be a base model that you get. That base model may not be intelligent. It is like a kid that you are slowly you are training. Initially the kid will learn how to crawl, then walk, then run, right? So like you should train that kid slowly so that it can become more intelligent. So the initial output that you get may not be the greatest. So you should evaluate that model. Is it fit? Is it good? So if it is not good, again you have to train it. So is it good? Not good, again train it. So you should train it so in such a way that you should evaluate at every step whether your model is in a usable format. Once you evaluate it is good, then there comes your ML is done. then it comes your integration step. So probably you should integrate this intelligence or a model that you got. Probably should integrate that with any of your ongoing systems, because it doesn't make sense to be sitting idle, right? It should, the intelligence factor that you derived out should be put in place into your existing life cycle, or existing products that you use, or existing domain that you're already working, or any of your websites, or integrate with something. So that integration factor will come. Then then it is in production now, right? It's already in use. Now it's time to monitor it. How is it performing in production? So monitor, debug, or refresh. So refresh is like you monitor it. You find some bugs. Probably you need to debug it more to get why this output has come. So you need to put some debug points in production to identify. So all those monitoring and debugging is very common factor. And then finally, probably you see some bugs in this process. Probably you should train it again. Again, come back to the same cycle. Again, coming back to data, give more clean data or more latest data. Train the model, get a version 2 of it. Again, deploy it, monitor it. So this life cycle goes on. So in this process, you find some bugs. Then again, you have to again this life cycle starts. Like you'll again train, get more data, clean it, do it. All this entire life cycle starts. So that's how this life cycle process is. So if you look at the main machine learning is only these two boxes, right? I mean, but the work before and after are also equally important. And in fact, the first three boxes is where you spend most of the time. In 70% of the time, I read some article like 70% of the time is spent on this rather than this. So that was a very interesting point. I mean, most of the time that most of the data scientists spend is more cleaning the data, transforming it. So that is the most time that was spent. So because unless I mean the garbage in, garbage out, right? So unless you give clean data, you will not get a proper output. So that's why this step is more important. So and this is where all your tools from this cloud providers will help you. So it starts from in terms of the data, right? So this is, I think, the data labeling that we just discussed. The data labeling is one step here. So once you identify, once you evaluate, you infer something, and so you'll associate a label to the data, so that next time when the same data comes, it can process it faster. So this build step is where you need to integrate your notebooks. I mean, all your notebooks is where developers will use. So you have to integrate your the notebooks. Notebooks is like developer workstations. So where you need to integrate this notebook with your Git repository, and also you should also enable the security features like VPC, end-to-end encryption, and more. So all this build step will come. And this is your then the manage step. Manage step is where you need to integrate. I mean, this is more about managing is this. So you need to modeler your. I mean, you should use a modeler use case, and also automate the workflows with AWS step functions and Apache Airflow. These are the various workflow tools where you need to integrate your machine learning model. So Apache Airflow is a popular open source tool, which Google is also relying on this called Composer, GCP Composer. It's also based on Apache Airflow. So Apache Airflow is popular open source product in this category, where for any workflow requirements. So this will be Airflow will be a best suit. So yeah, in machine learning also this Airflow comes into picture. Then of course leaderboards and lineage tracking. So this is where you do the manage part of all your services. And the training part is where this part I'm talking about. This training part is where you spend most of the time in creating a cluster, automated cluster setup and tear down. Once your work is complete, you will set up and then tear down, bring it down. So this cluster is forming a cluster and managing a cluster is what mostly is done in Kubernetes these days, because Kubernetes is a perfect cluster management software with containers. So mostly it is done in Kubernetes, but otherwise, if you're not interested to use Kubernetes, you can do your own ways of cluster management also. And of course, you need to, for training this, you need to use popular ML algorithms, right? So mostly you can either use a built-in algorithm, which is there inside the framework that you use. Yeah, it depends on the framework that you are using. And SageMaker in Amazon is a framework. So either you can use a built-in SageMaker framework, or you can use an open source solution, or you can use your custom ML algorithm. Let's say you're not interested in the built-in algorithms, you can define a come up with your own custom model algorithm. And then also the optimization of the cost, like such as early stopping and base and optimized automatic model tuning. So all this cost optimization aspect will come in because it is the training part is the major part, but training comes with a compute cost. So if you ignore it, it will immediately tremendously shoot up the uh, your uh, your compute cost because it is running on a huge GPU or CPU, high CPU or GPU based compute. So you have to maintain or keep a tab on your cost of your compute. So sometimes if you face any issues in between, it doesn't make sense to continue, right? So it should stop early. So probably you should look at some techniques where you can unnecessarily you don't want to spend time on a wrong output. When you know it is wrong, you can stop it right away. So that kind of techniques can be added or optimized automatic model tuning. So based on the data that we have, let's say the data is incorrect or data is invalid, sometimes your code can break. But if there is any model where it can tune based on the wrong output, or let's say you can ignore that logic, ignore that data set, and proceed with the rest. So that kind of some optimizations can be done so that it can at least you get some output rather than stopping that flow entirely. So that is about the training part, and the deployment part is where you need to manage your. You have the output now, so you need to use that output and you deploy it into production, and you want to monitor it. So in this process, you need some tools where you can manage the inferences of the cluster because all this model that is running out that you got, they'll be running on some cluster. So managing that inferences from various clusters is tricky. Meaning your same model that you got will be running across multiple environments or multiple clusters. So getting the output or debugging that would be a bit tricky. So that's where you need some tooling around that. And also it could be a batch based or an auto scale REST based or a real time services. So yeah, there's a variation also here where it could be batch or it could be REST or it could be real time. So various combinations are there. So this adds more complexity there. And also this integration with monitoring tools like in AWS CloudWatch is a monitoring tool. So you need to integrate your machine learning services with CloudWatch or any monitoring tool in the cloud. So and also optimizing the hardware with new compiled models. So that the hardware that you're using is meant for machine learning or for example the hardware. I think that is now another trend. I think the software that we're developing is to some extent only it will help you to give better results. Let's say you're looking for a faster query time or faster processing time. You need a special hardware. So NVIDIA is one such company where it can. Most of the all the cloud providers are more or less tying up with NVIDIA graphical processing unit. The graphical processing unit hardware is built by NVIDIA, and that is becoming so popular now. And the versions that they're releasing is changing every day. So and it is giving better results with the least amount of time. So yeah, this optimizing hardwares also plays a major role. So that also should be considered in the deployment phase to get a better results. Yeah, so I think it looks simple, but I think if you see small bits and pieces, it has become its own. There are a lot of problems inside, right? Starting from data gathering to training to evaluation to deployment. So the cycle goes on. So that's where all these toolings are helping you to make your life easier. So, yeah, is it logical? And I think this one also it makes. I mean, this is also one area. I think this is again.
Sham, today is a good dosage, right? So,
Yeah.
do you want to continue now, or is it a good time for break?
Yeah, we'll break. I think I'll just stop here. Just a logical point. I'll finish it here.
Okay.
So, yeah, I think this is. I think this is more related to the input that we just discussed. I think the public safety model, right? I think this is one example where they take the crime report data that is available on public internet, and they're taking that as an input, and they do the initial labeling, whatever is possible. So if they have any initial information in hand, so they can add labels to the data, and so that is the input. So for your machine learning, and from that you will pass that input to your pipeline. So the pipeline will start. It will crunch that data and then come up with a machine learning model. So this is the output of the first output that you get. Probably this output may not be a best model, but I think it's a good starting point. But now this model will be used to evaluate. So now you with the model that you have, you see whether you can check whether the future crime that can this happen or not on a particular given date or given time. So you want to, and it will give some output, but that output you can check whether it is valid or not. But if it is valid, that's good. If it is not valid, then it means that you need to train this even better. So that's where this prediction will check. The prediction that it is making, whether in future something will happen or not, yes or no. So the prediction is good, then it's fine. Otherwise, if prediction is not good, then you need to readjust the model, which means you need to retrain it again. So so finally, if they say the output is good, then then you will label that data saying it's a good data, so that the data set that you're using it can be used further again for further training, so that it can be made even better. So it can process faster. It will use that data for most. It will give more weightage to the labeled data when it is processing. So yeah, I think that is what I want to highlight. But I will break here.
Yeah, I think it's a good deep dive session.
Yep.
So from next week onwards, we are going to go with the practical side, or what is your plan?
Yeah, I think this one the IoT space is pending. Probably every day I was thinking that is my last session, but it's it's always one thing pending. The IoT is the only thing pending in the comparison slide, but probably yeah.
Yeah, IoT actually, since you have a little bigger background on that industry IoT also, you could bring that in also along with these cloud providers. What is actually they are claiming and what is the reality as well? Thinking on that.
Yeah, okay? Sure. Yes.
Because not everybody has adopted cloud yet, right? In industry IoT, right?
Yeah.
Yes, yeah, it is going slow. I think it is not as expected, but I think the predictions are huge for in terms of usage. But I think it goes in combination with the AIML. I mean, IoT as an area where this is a one area where AML can go hand in hand to make it even better or make the devices more intelligent. So yeah, I think it is evolving.
Oh, okay. So, Kasi, anything from your side you want to?
No. I'm preparing for DP 200 and 201 actually. So this month I cannot do anything. after I complete this, then I'm going to jump into that Snowflake. That's my plan. So in that Snowflake, I can start do something. It's like
Yeah. No pressure. But what I'm saying is, at any point, whenever you want to say something, or if you have a slide or something,
okay.
let us know in the initial itself, so that in between you could do that. Okay.
Definitely, yeah.
Yeah. But I think others also
sounds good.
can pitch in. I think it is interesting. So that way it will add not just one person or 2 person talking. Right? Probably it is good to have other people in the conversation.
Yeah.
Yeah. Probably if there are any volunteers,
Okay,
please
thank you.
send emails so that we can plan this better.
Okay.
Okay.
Okay. See you. Bye.
Okay.
Yeah, thank you.
Thank you everyone. Bye bye.
Yeah. Bye.